Lesson 3-8 practice. Are they similar? Question 1. This is an invalid proof that all isosceles triangles are similar. Draw two isosceles triangles ABC and DEF, where AC equals BC and DF equals EF. Alright, you can see that AC equals BC, DF equals EF. Dilate triangle ABC to the new triangle A prime, B prime, C prime using center C and scale factor DF divided by AC so that A prime C equals B prime C and DF equals EF. Alright, so dilating, the center is C, and the scale factor you can see is about 1.35. Alright, translate the directed line segment CF to take A prime B prime C to a new triangle A double prime B double prime F. Since translation preserves distance, A double prime F equals A prime C equals DF, and B double prime F equals B prime C equals EF. Alright, we're going to translate it from C to F. Since A double prime F equals DF, we can rotate using center F to take A double prime to D. Rotate. Rotate center F, taking A double prime to D. Since B double prime F equals EF, we can rotate using center F to take B double prime to E. Rotate center F, taking B double prime to E. And you can see it moved it off point D. We have now established a sequence of dilations, translations, and rotations that takes A to D. No, it moved it off D, B to E, and C to F, so the triangles are similar. All right, step 6 is invalid. Transformations act on the whole plane, so when we rotate in step 5 to take B double prime to E, our sequence no longer takes A to D, and I just showed you that. Question 2. Which statement provides a valid justification for why all circles are similar? Well, all circles are similar because you can translate and then dilate them, and then they'll be congruent. I can translate the center of any circle to the center of another and then dilate from that center by an appropriate scale factor, so they must be similar. Question 3. Which pair of polygons is similar? All right, 12 divided by 4 is 3. 5 divided by 3 is not 3. All right, these are all 90-degree angles. These are not. They have to have the same angle measurements. These are all 90-degree angles. 1 times 2 is 2. 1 times 2 is 2. 5 times 2 is 10. 5 times 2 is 10. And the corresponding sides are proportional. 5 times 2 is 10. 6 times 2 is not 6. Question 4. Refer to the figure. The length of AC is 6 units. Select all sequence of transformations that would show triangles ABC and AED are similar. Dilate triangle ABC using center A by scale factor of 1/2, then reflect over line AC. All right, dilate 1/2, reflect AC. Yep, that worked. Dilate triangle AED using center A by scale factor of 2, then reflect over line AC. All right, this time we have this triangle. We are going to dilate by 2 and then reflect. And you can see that obviously worked. Reflect triangle ABC over line AC, then dilate using center A by a scale factor of 1/2. So reflect, then dilate. You can see that worked. Reflect triangle AED over line AC, then dilate using center A by a scale factor of 2. Again, reflect, then dilate. That worked. Translate triangle AED by directed line segment DC, then dilate using center C by scale factor 2. So translate from D to C, and then dilate by 2. Well, that would work if we did one more step, which is reflect, but they did not translate either triangle ABC or AED by a directed line segment. We did that. That's the step, right, when we translated it. And then reflect over AC. So you hit reflect AC, and you can see that would work also if we dilated, so which they did not. Question 5. This question has 2 parts. First answer part A, then answer part B. Complete the explanation to determine if the statement must be true, could possibly be true, or definitely can't be true. 2 equilateral triangles are similar. Blank be true. Well, that must be true. We proved it in class using the Desmos geometry calculator. So that must be true. Dilate the first triangle using any center by scale factor that is the ratio of the lengths of sides of the second triangle to the lengths of the sides of the first. Second, first, to find the scale factor. Second divided by first. Then apply the blank triangle congruence theorem. Well, if they're similar, all the angles are congruent. And the dilation proved that one of the sides between 2 of the angles are congruent. So that would be angle side angle, angle side angle. Complete the explanation to determine if the statement must be true, could possibly be true, or definitely can't be true. An equilateral triangle and a square are similar. That cannot be true. A triangle is not similar to a square, so cannot, must, could, definitely can't. Rigid motions and dilations both take line segments to line segments, so the image of the polygon must have the same number of sides. Yeah, a square and a triangle don't have the same number of sides. Question 6. Refer to the squares. Complete the sequence of rigid transformations and dilations that take square EFGH to square ABCD. Translate square EFGH by the directed line segment. Well, we're going to translate from E to A. They're both the first letters, E, A. Translate EJ. All right. Then rotate the image using center A by angle. All right. Rotate center A, and the angle would be F prime A B. F prime A B. You can see that F and B are both the second letters. Finally, dilate using center A by a scale factor. Well, I calculated this one. It's really not 5/2. It's closer to 3. So if I dilate this, it would be the center is A, and it would be about 2.95 or 3, right? 2.96. If you round to the 100th place. But theirs is 5 divided by 2, 5/2, 5/2. Question 7, refer to the figure, select all true statements. Angle ACB is 180 minus X. No, angle ACB is X. They are corresponding angles. Segment ED and BC are parallel, and that means angle ADE or X is the same as ACB. So ACB is X, not 180 minus X. Triangle ACB is similar to triangle ADE. Yes, their angles are congruent, and their corresponding sides are proportional. That is true. AD equals 1/3 AC. AD equals 1/3 AC. Yes, 2 is 1/3 of 6, right? 2/6 is 1/3. And then finally, AD equals 1/2 DC. Yeah, AD is 1/2, as AE, which is 5, is 1/2 of EB, which is 10. AD equals 1/2 of DC.